Hi everybody, it's Miss Austin and I'm going to be going over the Unit 4 Lesson 3 practice problems. 1 through 7, and these start on page 165. The first question says, select all solutions to m times m times m equals 729. So something times itself 3 times or raised to the third power is equal to 729. And so I think it's useful when it's written as a radical to maybe think of it written with rational exponents, right? So that means 729 to the 1/2. And a number times itself 3 times, that means m to the third. So I'm taking this number and I'm raising it to the third power. That's going to end up being 729 to the 3/2, which is not 729. No. Okay. This one, I can already imagine if I take this number times itself 3 times, what's the denominator going to be? 3 times 27. And this is just regular 729. 729 times 729 times 729 is a huge number. Divided by 27 is not 729. I don't even want to figure out what that top number is. Here, this is a combination of A and B. I already know 729 times itself, the square root of 729 times itself 3 times is 729 to the 3/2. All over 3 is going to make the bottom of 27 again. That's not going to work. D, if I multiply 1/3, the number 1/3 times itself once and again, it's going to make 1/27. And then this is that number again, 729 to the 1/2. So that's going to be 729 to the 3/2 times 1/27. No, doesn't work. Are any of these going to work? All right, the next one, 729 to the 1/3. Well, I'm taking this number and I'm raising it to the third power times itself 3 times. What happens there? Right? If you want to imagine there's a 1 under there, so that's 3 over 3, which makes 729 to the first, which is 729. That means cube root, right? But it's kind of helpful to look at it this way. E works. And F, this is actually the exact same thing written in radical form. If you want to imagine it, if you take the cube root of a number times itself 3 times, right? That undoes the cube root. Or think of it like this again. The cube root means 1/3. 729 to the 1/3 times the 1/3 times the 1/3 is 729. E and F. Could also use your calculator if you wanted to. In a pond, the area that is covered by algae doubles each week. Okay, this is an important word. When the algae was first spotted, the area it covered was about 12.5 square meters. Find the area in square meters covered by algae 10 days. Look at the difference there after it was spotted. So the normal rule is y equals the starting amount. It's doubling, that's 2, and to the x power. But this is in weeks. But I've got 10 days. So how am I going to do that? I'm going to write that as a fraction, right? 10. Normally, if you think about it, if I put a 1 in here, that stands for 1 week, which is 7 over 7. Why am I using 7? Because there's 7 days in a week. And why do I want to do that? Because now I've got days. So instead of this being 1 week, it's 10 days. So I'm going to put 10 over 7 in here. So I'm going to type in 12.5 times 2 to the 10 over 7. Now, if you're using a calculator, you might want to be careful here. I've got 12.5 times 2 to the, since it's a fractional exponent, you need to put it in parentheses. 10 divided by 7. So the new area of the pond that is covered by algae is approximately 33.65 square meters. Explain why we can find the area covered by algae 1 day after it was spotted by multiplying 12.5 by the 7th root of 2. Well, let's look at this. Let's look at the rule again. This is in weeks. If I only want one day, right? Let's switch this. So 7 out of 7 is 1 week, right? But I only want one of the days of that week. So I would do 1/7. So technically I want 2 to the 1/7. But remember, what does that mean? That actually means the 7th root of 2. Those two are the same thing. Remember, we just talked about that on number 1? 729 to the 1/3 is the same as the cube root of 729. Okay, so why can I multiply it by the 7th root of 2? Because really what I want, I'll write it out, I want the 1/7, but this right here just means the 7th root of 2. Okay, so either way would work. And they don't ask us to find it. All right, moving on. Number 3. The function m defined by m of h equals 300 times 3/4 to the h represents the amount of medicine in milligrams in a patient's body. H represents the number of hours after the medicine is administered. What does m 0.5 represent in this situation? Well, H says it's number of hours after the medicine has been administered. Well, that says a half. So it represents the amount of medicine 1/2 hour after given, or 30 minutes, or 0.5 hours, however you want to say that. The graph represents the function. So somebody type this in. You could go to Desmos yourself, type that in, 300 times 3/4 to the h. Here's what it looks like. Use the graph to estimate the answer to this. So it says 1/2. Well, 1/2's right here. What do we think? That's 250. That's 275. I'd say approximately 260. Somewhere around there. You don't have, I don't know, 262, 258, something, about 260 milligrams. We could also use the rule and see, but it didn't ask us to. Suppose the medicine is administered at noon. Use the graph to estimate the amount of medicine in the body at 4:30 the same day. So if time 0 is 12 o'clock noon, they want us to go to 4:30. That's 4.5 hours later. So 4.5 is about right there. Let's see. That's 50, that's 75, I don't know, about 80 milligrams. And this one, I didn't really write the answer, but I'll point to it right there, the one up above. So sometimes you can answer questions from a graph, sometimes you can answer things from a rule. They did give us the rule to that one as well. We could double check how close our predictions were. Let's see. The rule was 300 times 3/4 to the 0.5. That was the first one. Oh, 259. Yeah, we said 260. Now let's do the next one. 300 times 3/4 to the 4.5 hours. 82. I said 80. Okay, but we're estimating off of the graph. Number 4, the area covered by a lake is 11 square kilometers. The area. Oh, just the land. Sorry, I was like, is this supposed to be an algae problem? The area covered by a lake is 11 square kilometers. It is decreasing exponentially at a rate of 2% each year and can be modeled by A of t equals 11 times 0.98 to the t power. By what factor does the area decrease in 10 years? Well, each year it decreases. This is the decay factor, so it'd be 0.98 to the 10th power, whatever that is. Figure it out. 0.98 to the 10th power. It ends up being 0.817. By what factor does the area decrease each month? Okay, this rule was written in years. So if I, right? So let's think about that. 0.98 to the t. This is in years. If I want to switch to months, then I need to create a fraction, right? 12 out of 12. There's 12 months in a year. 12 out of 12 is 1. But I want to just do for 1 month. So I would switch the numerator to 1 out of 12. So in 1 month, it would decrease by 0.98 to the 1/12th, or you could write it as a radical, the 12th root of 0.98. That's what you could multiply it by to figure out in 1 month. All right, number 5. The third and fourth numbers in an exponential sequence are 100 and 500. Let's write this out. 1, 2, 3, 4. So this is 100, 500. And they told me it's exponential, which means we're multiplying every time. So I can clearly see from here to here, I multiplied by 5. So how do I go backwards? What's the inverse of multiplying? Dividing. What's 100 divided by 5? 20. What's 20 divided by 5? 4. Make sure it works now. Am I multiplying by the same number each time? Yes. 4 times 5 is 20. 20 times 5 is 100. Yep. So 4 and 20. This is my first term. This is my second term. All right. Last problem. The population of a city in thousands is modeled by the function f of t equals 250 times 1.01 to the t power, where t is the number of years after 1950. Which of the following are predicted by the model? Select all that apply. I almost fell for A when I first did this, right? But it says the population of a city in thousands. So that stands for 250,000, not 250. So no. The population was 250. Yes, remember in an exponential rule, this is the starting amount. This said 1950, that's the starting amount in thousands. Yes. The population grows by 1% a year. The number in here is your growth or your decay factor. When it's growth, it's bigger than 1. To see the growth, you look at this part. The 1 is always there. That's bringing the 100% of the term before it, and this is bringing the extra. 0.01 is 1%. The population in 1951 was 275,000. Well, I'd have to figure this out. 250 times 1.01, 1951 would have been 1 year later. So let me do this. Maybe some of you already know the answer, but without a calculator. Is 1% of 250 going to bring me up to 275? No, I'm only at 252.5 thousand people the next year, not 275. Nope. The population grows exponentially. Yes, this is an exponential function. How do I know? Because the variable is in the exponent position. I hope that helped, and I will see you soon.